Hello everyone, I'm Barkley Hunter, and welcome back to the MATLAB and Simulink tutorial for Best Robotics. In this second episode, we'll be looking at the basic programming functions of Simulink, as well as the most commonly used blocks in the VEX library that you'll be using for Best Robotics. If you haven't watched episode 1, that is about installing the program, so if you don't yet have it, then make sure to watch episode 1 first. Now let's get started by switching over to MATLAB. MATLAB is a code-based programming system, and while you do have the option to use it within your Simulink program, Simulink will be your main resource for programming the robot. This is a basic Simulink interface. There's a single input block and a single output block. Right now the program is too zoomed out to work with, but Simulink offers a couple of easy ways to zoom your program. One is to simply use the scroll function on your computer, whether it be a mouse wheel or sliding on your touchpad. The other is to press the space bar, which fits the blocks in your program to fill the screen. Now that we've got them in a usable state, we can line up the input and output blocks by simply clicking on one and dragging it to the position where we want it. As you can see, Simulink will help you to line your blocks up vertically and horizontally in order to make your program more readable and allow you to visualize the flow of information. As you can see, I drew an arrow between the input and the output blocks. The arrow between the blocks represents the data flowing from the input to the output. There are a few different ways to draw arrows. One is to drag from this output arrow on the input block to the input arrow on the output block. You can also do it in the reverse direction. And when you line up blocks using symmetry, Simulink will offer you a guide to automatically place an arrow. You can delete an arrow by clicking it and pressing the delete key. This system of placing blocks and drawing arrows is the very basis of Simulink programming. Where the complexity enters the system is understanding what each block's function is. To get started on that, we'll go back to the VEX companion app that we installed last episode. We'll start by opening the library within the VEX support package. This contains the most essential blocks for the best competition. On this opening menu, we have 9 different blocks and also 3 different libraries. In these 9 initial blocks, the most important are your 2 main outputs, the DC motor and the servo motor, and your 2 main inputs, the gamepad button and gamepad joystick. We'll start by looking at the inputs. The gamepad button uses the digital buttons that can be found on the front and back of your controller to make a binary output of 1 or 0. The gamepad joystick uses the 2 different joysticks on the left and right of the controller to create an analog output that you can use to control your motors. To view the initial options of a block, simply double click on it. We can't edit it in here because we're within the library, but the basics are the channel and the button. The channel determines what set of buttons your gamepad will look to determine the output from the block. Channels 5 and 6 are the bumpers on the back of the controller that have up and down buttons to give an output. Channels 7 and 8 are the front-facing 4-button keypads. These have up, down, left, and right options that you can use for even more outputs. The gamepad joystick has joystick number and analog channel. Joystick number, like in the last button, only gives the number of controller. So if you're only using one controller, you will always set it to joystick number 1. The analog channel is used to determine what axis of what joystick you will use to get the output. Each joystick has an up and down and a left and right axis. as you can see in the diagram, axis 1 is the left and right on the right joystick. 2 is up and down on the right joystick. 3 is left and right on the left joystick, and 4 is up and down on the left joystick. Your two main outputs are your motors and servo motors. The motors come in two different kinds for Best Robotics. There's a large motor and a small motor. The large motor is more powerful than the small. However, Simulink does not make a difference between the two different motors, and you'll use this block for all of them. The only option that really is of concern here is the motor channel, which is what port your motor is plugged into within your VEX microcontroller that you'll have attached to your robot. If you specify this, then it should feed the correct output to the motors. Your servo only needs the motor channel as well. The difference between the motors and the servos is that the motors are free spinning and can spin continuously in either direction, and the servos can only spin between positive 60 and negative 60 degrees from their starting point. Now let's look at the libraries and see the most useful blocks in each of them. Within the logical operations library, there's the and not logical operators. Either of these can be changed to any other type of logical operator, such as OR, NAND, or XOR. These are often useful for simple logic within your programming. The most commonly used blocks within the math library are the addition, subtraction, and gain blocks. The gain block is used to transfer the binary output from a button of 1 or 0 into a larger number to control a motor or servo. In this way, it acts as multiplication by multiplying the 1 of an activated button into, for example, a 45 to orient a servo to 45 degrees. Lastly, the most commonly used blocks in the utilities library are the latch, which allows you to have a button continuously set itself to 1 once it's pressed until it is pressed again, at which time it will set itself back to 0. And the simulation blocks. The gamepad simulator is useful if you have a Logitech gamepad F310 controller, which you can purchase from most major stores, that you plug into your computer via USB and can use to simulate your program using an actual controller. The variable input allows you to shift the input along a range of numbers to simulate different speeds coming into the motor or different angles coming into the servo. The constant is set as a continuous number at all times to use for math operations and logic operations, and the toggle switches between 0 and 1 when double clicked to simulate clicking and unclicking a button on the controller. For output, you will commonly use the display, which will show the speed of your motor or the angle of your servo, and the field simulator, which will allow you to connect your motors that are being used for wheels and simulate them being driven around a two-dimensional plane on the screen of your computer. This is very useful for making sure that your motors are oriented correctly and that your steering is telling them where to go correctly. Now let's look at a few more basic tips for programming within Simulink. You can click and drag to create a field and select multiple blocks. And just like with the arrows, blocks can be deleted just by pressing the delete key once blocks are highlighted. To access new blocks, simply find the library you want and then click the block you want and drag it from that screen into your program. This will transfer it into the program where now its options will be fully editable and it can be connected to other blocks within the program. If you need to search for a block, if you forget where it is or can't find it, then you can search for it by name by single clicking on the background. A magnifying glass will appear, and you can type the name of the block and then press enter once it's selected, and MATLAB will automatically insert it into the program. If you double click anywhere in the white area of the background, you can insert a comment. This allows you to make notations and remember various things about the robot program. All of these are the most essential skills that you'll need to create a clean and easily understandable program that will let your robot run. In the next part, we'll be covering how to combine these different skills and these different blocks and create functional systems to run different parts of your competition robot. Stay tuned for the next part in the coming weeks. Until then, good luck practicing with your MATLAB and Simulink in preparation for the Best Robotics competition. Goodbye.